Hey, welcome back to another training video. I'm Chris, and today we're going to be jumping in Conversational Cam Pro, CCAM Pro, specifically with a toolpath called Import Vector Turning. This will give us the ability to create contour turning designs when traditional cutter profiles just won't work. So to help answer two questions, we're going to answer one is, what is import vector turning? What does it do? And two, how do we program it? And so we're going to cover those two questions today. To help visualize this, we're going to be using our Vectric software, which is a key element in producing the actual toolpath at first, and then we're going to bring it into Conversational Cam Pro to convert the G code for contour turning procedures. So this is a really interesting but awesome way of producing contour turnings. We'll then finish off the video by going into the actual cutting results, showing the machine in action and explaining what is taking place. So let's jump on over to our Vectric software to see what we need to do. Okay, so for this design, we've already in previous videos, we have done two toolpaths to the spindle. First, we took a surfacing cutter and we actually turned it round across that cylinder section all the way across. And then second, we took our 2-inch classic spiral and did some turning tool profiles here, here, and there. And if you haven't seen those videos on how to do those, I highly recommend it. They are definitely key turning elements for most spindle designs. This video is no different when it comes to the vector turning process. It is one of the most common, most popular turning elements that you're going to be using on Legacy's Turning Center. So let's set up what we need to do here. So the toolpath itself for these original turning round and turning tool profiles were all done in CCAM Pro. The G code that's going to end up in CCAM Pro is also going to be generated from CCAM Pro, but the original G code is not going to start from CCAM Pro for this vector turning process. The way this is going to work is we're going to create an actual curved design here, and we're going to generate a 3-axis toolpath, and then we're going to take that G code that we generate here in the Vectric software, and we're going to import it into CCAM Pro to convert it. Okay? So in order to do that, though, we have to set up this part correctly. So I'm going to go here to my job setup. Originally, it didn't matter where our X and our Y 0 and our Z0 was all placed throughout this process. In this particular toolpath, it does. Okay, so we still want X0 to be on the left side of our spindle, but we need Y0 to be in the center of our spindle, because the center of rotation is where Y0 is in our turning center for the machine. To do that, we're actually going to use what's called a offset position here in the datum. So if we check use offset, I'm going to put a negative y-axis offset, just half the width of the y-axis. So 2 3/4 is going to be 1.375, but again, I'm going to put a negative in there so it shifts in the right direction. There you go. So you can see it now puts the Y down the dead center of our spindle, which is exactly where we need it to be. So that is the only critical step that we needed to produce for this process. It doesn't matter where our Z0 is located, same as the material thickness. So those are the only changes that we had to make to this part. So let's push OK. And now let's lay out a design of what's going to take place. So contour turning is where we're not using the shape of a cutter to quickly cut or turn a profile, but we're actually going to be creating a custom curve of some kind. So I'm going to draw just a polyline here. And so we're going to start from the end of this routed bit profile here. And I'm just going to click a couple of times just to create a few points of contact, and we'll finish that off. Okay. Now we're going to actually turn this into a curve. So if we go here to our node editing, and we're going to change all of these nodes to smooth points. I'm going to do it to all of them. Okay. And now what we're going to do is I'm going to adjust these nodes until this turns into a very appealing curve shape that I like. Okay, so I'm just going to be modifying these node positions until I find something that I really, really like. Okay, we're getting actually pretty close already. So I like how this transition is happening and it's gradually coming down. Let's move the end of this node here till it just kind of meshes and transitions. You can see it's kind of crossing a little too much there. Okay, so it's just transitioning right into the curve of that cutter. and that will work beautifully. Okay, so if I unclick that, you can see that curve take place. Let's take this curve and we're going to mirror copy it to the other side just so we can see what the actual result is going to be. And awesome. Okay, so that creates an actual contour effect. If I didn't like the results after I mirrored it, I can always take it and modify even more. Perhaps I wanted to shift this over here so that it's not again, as elongated for the contour, but a little more shorter before it starts dipping down. This is all preference when it comes to these types of points, okay? So let's say I liked that shape a little bit better. Well, I can always delete this one, and I can re-mirror copy this one. And looking at that, I like that better, just from those little changes. Makes it look a little more elegant. Okay, so that's just my personal preference. After that, we can actually delete, this isn't required for programming, but we can delete all these other lines because all that material is going to be machined away from this contour effect. So these lines will disappear. We can actually take and trim away these lines here. And there we have a beautiful contour being brought into what's already been done to this spindle using the turning tool profiles with these cutters. Okay, so the key thing about this toolpath is that, again, we can't use a traditional shape of a cutter to do this. For example, I can't take something like this to create a contour. The only way to actually turn contours that are as reliable and consistent is to use a ball-shaped cutter. Something that the tip of the cutter has a radius or a ball to it in some way. So this is for example, a tapered ball cutter that tapers down to an 1/8 inch ball on the point. You can use larger diameters. What you're limited to is what the tightest radius is going to be in the design. Okay, this is a go-to for this size of 1/8 inch taper ball cutter is a go-to for a lot of contours because it can get tighter into these kind of square crevices if my contour effect again was really unique in getting into unique shapes. Okay, this is pretty gradual, and so this will work just fine using that same cutter. So we're going to be tool pathing this using the 1/8 inch tapered ball cutter. Okay, so with that in mind, let's actually select this. And we're going to go generate an actual toolpath here in Vectric. So the one we're going to use is a profile toolpath. And what we need to do simply is to make sure it doesn't matter what our cut depth is as long as it does it in one full pass. But there is one critical thing that we have to pay attention to based on the shape of the cutter that we're using. Okay, so I mean this cutter has you can see the shape of the cutter goes from the point all the way up here to the end of the taper. So that technically is the profile height of the actual cutter, which is about 1 inch. And so I like to have my cut depth greater than the profile height of the tool that I'm going to be using. That makes it so that the Vectric software doesn't accidentally shift my cutter the wrong distance away from the original contour line. Okay, so that's why I have a big cut depth here of 2 inches, and it's going to do it all in one pass. That again, it's not going to actually do that for cutting from the side. This is what we're simulating. We're simulating this in this software as if it's cutting from the side of this contour effect, just a flat stock component. But again, that G-code is going to get brought into CCAM Pro and be converted to cut along the top. Okay, so we're going to be doing something like this. It's going to take think of it as an 1/8 inch cutter cutting from the side here, right? And it's following along this contour to, again, cut this out. And that's what's going to take place in this toolpath that we're programming. But in CCAM Pro, it's actually going to convert that G-code to cut from the top like this. Okay, so it's going to be following along that contour face, cutting along the top. So that's why we have to start it with a flat surface and try to lay this out to where there's not multiple passes, only one pass. And we have to make sure we're cutting on the correct side of the line. So if I select my contour effect, I always cut on out of the 2 contours, I always choose the top one. And so we're going to cut on, starting at this point, on the left side of the actual vector. So that's why I'm choosing left with a big cut depth at 1 pass. And make sure that we're using the same diameter of cutter that we plan to use in CCAM Pro for the tip of the ball. Okay, so here I've chosen an 1/8 inch ball cutter. Okay, and it doesn't matter what the tool number is, what the feed rate is, what the spindle speed is. all of that is going to be overridden in CCAM Pro. All we have to pay attention to is to make sure the diameter is the same as what we want to use in CCAM Pro, and that the cut depth, okay, is covering the entire cut profile greater than and is done in one pass. Those are all the critical items. Other than that, all we have to do is come down here, give it a name, such as, I'm going to call this import contour to remind me of what this G-code is used for. I'm going to be importing it into my CCAM Pro software, and we can push calculate. Okay, so that gives us again a 2D layout, but sorry, this is actually a 3D layout of what the toolpath is going to do. You can see it's going to cut 2 inches deep. But what I want to pay attention to is I'm going to go back to my 2D view here. I want to make sure the cutter is on the correct side of the line. For example, here, if the toolpath was on the other side, it would be cutting too deep, right? We wouldn't be actually getting the right diameters and the contour effect. We need to make sure the cutter's on the correct side. So that's all I'm verifying. So this represents the center of the cutter traveling down the edge of that line, and that is correct. So now we're ready to save out our G-code. So if we close our preview here and we go to Save Toolpath, we need to select a specific post processor for this specific technique. And here we have updated the name to keep things uniform for you guys. It's called the Legacy Delta Vector Turning Post Processor. And you're going to find Vector Turning as the name in CCAM Pro as well, so that the names match up. So it's really easy to remember this process. Okay, so let's save out that G-code. And we'll put this in the Import Vector Turning demonstration folder that we specifically made for this video. And again, I'm going to keep this as Import Contour. If you want to put G-code on the end, you can, but I'm just going to leave the title as Import Contour and save. Okay, so we have done the first step of this process, which really isn't very difficult. It's just creating a vector shape and then assigning a toolpath, a profile toolpath to cut on the outer edge, or in this case, the left edge of the line down that length. All in one pass, right? So that's all we've done. So now we can open up CCAM Pro. And we're going to go back to the project that was created in the previous videos for this spindle. And we go to Training Samples. I'll select that project. I'll go to the workstation. And there we have the turning round sample project that we did earlier. And there were already 2 toolpaths from the 2 previous videos, the turning round process and the tool profile process. We need to add a new toolpath to this for the vector turning. So if we go here to Manage Toolpaths, and over here we have an option for importing vector turning. Okay, and that, again, this is the specific the specific toolpath that's going to convert the G-code that is generated from a third-party CAD/CAM software as a 3-axis component or a 3-axis profile cut, and it's going to convert it to a top cut following along the Z-axis, and it will add the rotation of the stock at the same time. So let's add that toolpath to our list, and now let's go do this conversion process. So we're going to go to Vector Turning, and the first thing we need to do is import our G-code. So let's go click on the field here so we can go find our G-code file that we had created. So that is right here, okay, under the Import Vector Turning folder, Import Contour, just barely save that out, and we can open that up, and that has now been imported into the software for it to use and convert. Now for the Delta system, okay, so you have 2 different controllers on your CNC's legacy CNC systems. For the Delta systems, you're going to have the option here for cutting mode of turning and indexing. Turning is what you're going to be using pretty much a majority of the time. If you have a Mach 3 system, it's not going to give you this option if you have a Mach 3 system chosen as your machine profile. This won't even show up as a questionnaire. It will always put it in indexing mode for your Mach 3 systems. Okay, just so you're aware of how the software is going to interact based on which machine profile you have selected. Okay, now this is already defaulted to say when it's rotating the stock throughout this contour turned process, it's going to be rotating the stock at 200 RPM. So again, just visually, as this cutter is traveling from one end all the way down to the next over here, that's just going to constantly be rotating at 200 RPM. Okay, so with that in mind, we just need to fill out a few more parameters and we're done with this toolpath. So the first one is our section diameter. And that is referring to what is the material that the cutter needs to approach so that we're not jamming the cutter into the material preemptively, okay? So for example, we've turned this round, okay, beforehand. We can actually measure this if you'd like. We turn this round as a vertical dimension to 2 inches in diameter. Sorry, 2.5 inches in diameter, okay? So that's where the material is around the entire cylinder being turned around. 2.5 inches is where the cutter is going to be entering the material. So that's the parameter we're going to put in our section diameter. This is where the cutter is going to meet the material at 2.5 inches in diameter. Now we get to choose the tool that we want to use. And so this is where we match the same, again, tool that we've been talking about the entire time, a tapered ball cutter using an 1/8 inch diameter ball on the tip. And I'm just going to use the 1/4 inch shank diameter for this tool. So we'll select that cutter. That's the one that I want. And we get to assign this to a tool number. Now, because this is being applied to a spindle that already has an existing tool pass tied to them, for example, the surfacing cutter is tool number 1 to turn the stock round, and the classic spiral was tool number 2 to turn the tool profiles. Here, we're going to make this one tool number 3, just to keep things in linear order of the cutters being applied to this spindle. Now, the last thing we need to apply, and again, these are all other things that we can control and do with the platform. We'll cover these in other videos. I just want to get you started with the basics. The last thing we need to make sure we're taking care of is what's called the step over. Okay. Now, you can have the system automatically calculate your step over, and the step over is how far the cutter travels down the stock per rotation. Okay, and this is going to be rotating at 200 RPM, and so it's going to be able to travel down the stock, you could say quickly per rotation, right? But it can't go too fast or else it won't leave a smooth finish. So what we found is that we made it so that this field will automatically calculate to take a 2.5% step over of the diameter of the cutter that you're using. So if we have an 1/8 inch tip, okay, 1/8 inch ball tip here, that means that it's going to take 2.5% of 1/8 of an inch for my step over. Now that works just fine, but I find, just so you don't have to do this calculation, I just want to show you what that actually means. And so if you took an 1/8 of an inch, again, ball cutter, and we multiply it by 2.5%, your step over is only 3/1000ths of an inch. Okay, it's really small. 3/1000ths of an inch per rotation as it's traveling down that stock. Now, here's what I found, is that anything smaller than 6 thousandths, so 0.006, you can't tell the difference in the finish. Okay, it's just too small to make any difference. So what I like to do is that if my step over is on a smaller cutter like this, is just going to be too small, we don't have to wait or cut it at that speed. We can actually just say, I want to do a manual step over and just make it 6 thousandths. I'm just going to round it up to the number that I found always gives me a smooth finish. If I was using a bigger ball cutter, like maybe a 1 inch, 1/2 inch, 2 inch diameter ball cutter, I would automatically calculate my step over. But for this one, for the small little tapered ball cutters, I always put in 6 thousandths. Okay, and we're done. That's all we have to take care of in this process, and we can go finish and save. Okay, so now we have the tool paths all combined together. However, instead of saving all of these out to G-code, again, we've already in previous videos done the turning round process and the tool profiles, the 3 tool profiles for the spindle. So all I need to save out for this program is just the vector turning, okay? Because that's all that's left over that's in the machine. So let's go generate that G-code. And this is now assigned that tapered ball cutter to tool number 3. And it's added and again converted this code for us. It's kind of simple to point out is that you still have the X positions, but instead of Y coordinates, that's how the G code here, when it was cutting here, generated from our Aspire software. It was doing X and Y movements to cut along the edge of the line. But you can see here that the software has converted all the Y-axes to Z-axis commands for us. So that now it's cutting from the top right along the Y0 position, directly above the material. So does all that conversion for us automatically, thank goodness, so we don't have to do that ourselves. And this is now ready to save out. So let's go save our G-code file. And I'm going to call this the vector turning G-code. And save. So now let's go out to the machine and see what it does. The first thing that happens before the cutter even gets to the material is that it's going to continually rotate it at that 200 RPM speed. Now the cutter will approach the section diameter of 2.5 inches. It parks at about 1/8 of an inch above that section diameter and then slowly works its way into the material. And so it might take a few seconds for it to actually make contact with the material when you're doing this the first time. The cutter is then going to slowly work its way down the material while constantly adjusting the Z-axis to give us that contour detail. So one thing I didn't mention back in the designing and programming steps is that I like to program this specific toolpath from left to right, or from headstock to tailstock. The reason I do that is because this turning process is always going to rotate this in a clockwise direction. And so if we cut from left to right, it will actually perform the entire cut as a climb cut, giving us a much smoother finish. In other videos, we'll also show how we need to rough out additional material before cutting this vector turning process, because we don't want to put too much load on the ball cutter. This is only taking about 1/2 of an inch of material at the deepest section, and these taper ball cutters can do that all day. Even though we're using a small 1/8 inch ball cutter, this whole process took just less than 5 minutes to turn. The ability to take a 3-axis G-code toolpath, a profile toolpath, and convert it for this vector turning is a game changer when it comes to this contour design effect. Originally, we had to break out each curve into separate arcs and program these as separate toolpaths for every single transitional point, but this has sped up the process immensely. Again, all of these cutting advantages are pre-built into our CCAM Pro software and will be applied to every single one of these vector turning toolpaths. Now, these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.